Greetings all the year 13 students and welcome to the fourth part of our topic on Strand 2.2. In this part, we are going to be discussing about the various ways in which we can represent the concentration of solutions. A solution is a homogeneous mixture which is made of two components, a solute and a solvent. When this solute is dissolved in a solvent, we get a solution. Majority of the component in solution is made of the solvent. In this particular session, we are going to be discussing the various ways in which we can describe the concentration of a particular solution. Most of the concentration expressions are going to use moles of the solute. However, there will be some concentrations which will be very less. In such a case, if the concentration value is very less, we are going to be using a different kind of expression like parts per million. So let's see the different types of concentration expressions and how we use them in our calculations. The ways in which we can describe the concentration of a solution is by using mole fraction. Mole fraction is a unit where the mole of solute is divided by the total moles. Let's look at an example. In this question, we have to find the mole fraction of glucose in a solution made by dissolving 50 grams of glucose in 500 grams of water. So the first thing we will be doing is to find the mole of each of the component. We will find the mole of the glucose, where the mass will be divided by the volume, and then we will find the mole of water, which is a solvent. Let's use this particular formula now and substitute our values. So the mole of glucose is 0.28. Glucose is our solute, remember that. Divided by the total moles. So the total mole is a sum of mole of glucose plus the mole of water. And our mole fraction for this particular solution comes to be 9.98 times 10 to the power minus 3. Make a note that mole fraction does not use any unit. Molarity of a solution is used to describe the amount of solute of a particular solution per kilogram of the solvent. So this is the equation we use, mole of solute divided by kg of the solvent. Let's look at an example. Here we have to find the molality of a solution which is made by dissolving 250 grams of sodium carbonate in 500 ml water. So when we substitute our values, the first thing we do is to find the mole of sodium carbonate. So 250 divided by mR of the sodium carbonate, which is 106, and the moles comes to 2.36 moles. Now since the volume of water is 500 ml, the mass of water will also be 500 ml because the density of water is 1. Density is equal to mass over volume. So if density is 1 and the volume is 500 ml, then the mass of the water will be 500 grams as well. So we will be changing the grams of water from 500 grams to kg. That will be 0.5 kg. Now when we substitute our values, this is what we get. Moles of sodium carbonate, which is 2.36, divided by 0.5 kg of water. And the molality will come to be 4.72 molal. This can also be written as 4.72 moles per kg. Okay, so this is some of the ways you can write the unit of this particular expression. Molarity is one of the expressions of solutions where the mole of solute is divided by the volume of a solution. Let's look at an example. Here we have 20 grams of cane sugar, which is dissolved in 125 grams of water. So when we have to find the molarity of the solution, this is what we get. We will find the moles of cane sugar, which is 0.058 moles. And then let's substitute it in our equation. Now since the mass of water is 125 grams, that will be similar to the volume of water, which is 125 ml. Convert the volume from ml to liters, and that will be 0.125 liters. So the mole of solute is 0.058 divided by the volume of the solution, which is 0.125 liters. And molarity comes to 0.47 moles per liter. Most commonly used unit is molarity, okay, when we are finding the concentration of a particular solution. However, due to the fact that there's some concentrations which are very low due to their dilution, we will be using other expressions as well. So for these kind of solution whose concentrations are way too low, we will be using the appropriate expression such as parts per million by weight and volume, or weight percent and volume percent. So this is how the formulas can be summarized as: parts per million is equal to mass of the solute divided by total mass times a million, which is 10 to the power 6. Whereas parts per million by volume will be volume of solute divided by total volume times 10 to the power 6. Weight percent, on the other hand, will be mass of solute divided by total mass times 100. Volume percent, volume of solute divided by total volume times 100. So let's look at some examples now. A sample of commercial vinegar was analyzed and found to contain 4% weight of acetic acid. The density of the solution is 1.0058 grams per centimeter cube. Find the concentration of acetic acid expressed in molality and molarity. So the information we are provided is a percent of acetic acid. Out of 100%, if 4% is acetic acid, then 96% will be water, which will be the solvent. So the assumption we are making here is percent will be equal to the grams. So 4% of acetic acid will be 4 grams of acetic acid, while 96% will be 96 grams of water. So when we want to find the molality, we will first have to find the moles of acetic acid, where the mass, which is 4, is divided by the mR. Okay? Once you find the moles of acetic acid, we are substituting it in our molality formula. The moles of solute is 0.07 and the mass of water, which is 96 grams, should be converted into kg. So that will read as 0.096 kilograms. Okay, do your calculation and your molality will come to 0.69 molal. Next, let's see how we are going to use the same concentration, same solution and find the concentration in molarity. So when we have to find the concentration of this particular solution in molarity, these are some of the variables that we have to have. The density is given as 1.0058 grams per centimeter cube. We know the mass of solute, which is 4 grams, mass of solvent, which is 96 grams. So the total mass of the solution is 100 grams. Therefore, from this, we can find the volume of the solution. So volume will be equal to the mass, which is 100 grams, divided by the density. And it will come to 99.42 centimeter cube, which is same as milliliters. To find the molarity, we will just substitute this formula. Mole of solute, which is 0.07, divided by the volume, which is converted into liters. And molarity will come to 0.70 moles per liter. So students, it's time for the quiz of the day. So today's question is, let's check out our answers. So your answer should be 12.57 molal, 0.18 mole fraction, and 9.77 moles per liter of molarity. I hope you have understood quite well what the session was all about. Take care. We will meet in the next part of the video where we will be discussing about the third strand, strand 3.1. Until then, take care. Bye.